Alright, this is a video that's going to help with solving linear inequalities to be able to determine what type of solution set that we have. To start the problem off, I'm going to do the distributive property. So when I distribute 3 inside, that's 3 times 2, that's 6x, and 3 times 4, which is 12. I bring everything else down, and I try to make sure that students do that, so that way what happens is they keep track of where they are. Alright, now I'm going to combine some like terms. You'll notice right here I have a positive 6x and a minus 4x. Notice that I grouped that inequality, I grouped that negative sign or minus sign with the 4. So now I know I have 6 take away 4, or a positive 6 and a negative 4, which will leave me with a positive 2. I bring everything else down. At this point, I need to go ahead and start solving this for x. So I'm going to move all my x's to one side. So right here, the opposite of being a positive 2x is to be a negative 2x. I simplify. Well, these x's right here, a positive 2 and a negative 2, they cancel. A positive 2 and a negative 2, they also cancel. So at this point, I'm left with negative 12 is less than positive 3, which is a true statement. And what happens here is that, in this case, unlike other inequalities, in this case here, since this is a true statement, that means that I can plug in any number. I can plug in any number. And so what they're saying is that all real numbers are a solution to this linear inequality. So this is maybe a higher level question. It's not something we're going to see all the time, but it basically is testing the situation. So what they're saying to us is this: they're saying that I can plug in any number I want. I can take any number in the number system, decimals, fractions, positive, negative. I can plug it back into this, and it'll make this inequality true. So they represent our solution set in interval notation. Remember, this is called interval notation. They represent that solution set in interval notation from negative infinity to positive infinity. That means any number, any decimal, anything. Alright, it's open parentheses because of the fact that we don't actually know where negative infinity is. And we don't actually know where positive infinity is. We just know that that's a figurative location. It's a space that we can speak of, but we can never get there. And it's the largest possible positive and the largest possible negative. All right, this is number 31 off of suggested homework 7.4.